This conference will now be recorded.
Hello and welcome to you all. Today we are going to discuss some of the problems on arrays, and after discussing the 5 problems that I have already coded in Eclipse, then we will discuss about the classes and objects. So in the beginning we are going to discuss a problem of finding the transpose of a square matrix. So square matrix is a matrix that has the same number of rows and columns. So this is the example of a square matrix. So in this matrix, it's a 3 by 3 matrix. So we want to find out transpose. As you already know, transpose can be found by converting the rows into columns. So what should be the output? The output should look like I'm going to write that on this Eclipse as well. So if this is the initial matrix, a 3 by 3 matrix, so the elements are 4, 5, 6, 7, 8 and 9. This should be the transpose. Basically, if we convert rows into columns, we should get 4, 7, and the first column will become the first row, second column will become the second row, so 5, 8, and third column become the third row in the transpose matrix. So this is the case. So this is, if this is the actual matrix, then this should be the output transpose of the matrix. If you look at the actual matrix and the transpose of it very closely, you will notice that the diagonal elements of the matrix remains the same. So in this case, the diagonal elements are 1, 5 and 9, and the same in case of transpose matrix, the elements are 1, 5 and 9. And what happens if you want to find out this using Java coding? You have to just swap the elements above the diagonal with the elements below the diagonal. So you will swap this 2 with 4. So here you will get this 4, 2, and then you will swap the second element above diagonal is this 3 with 7. So these two elements will interchange their position. So you will get 7 and 3 over here. So this is the result. Then the third element above the diagonal is 6. So you will interchange it with the element just below the diagonal. So this is 8. So you will get 8 over here and 6 over here. So the basic problem of finding the transpose is just exchanging the elements that are above the diagonal with the elements that are below the diagonal. So if you look at the position of the element, this element is 0, 1. This is in 0th row and first column. And this one is 0, 2. And this one is 1, 2. So in all these cases, the index number here, the column number is greater than the row number. See here, if you look at this, the row number is 0, column number is 1. So column number is greater than the row number. And in this case, 3, the row number is 0, column number is 2. And again, in this case, the column number is of this element is greater than the row number. So for all the elements which are below, which are above the diagonal, for those elements, the column number of the element will be greater than its row number. So we want to interchange. If this is our 0, 1 element, we want to swap it with 1, 0 element. So this is basically 0 2 element. We want to swap it with 2 0 element at 2 0 place. This is the element 1 2, and we want to swap it with the 2 1. So this is how you can write the logic to I'm going to delete it right now. So here is the problem that I have already coded in Java. So let's discuss this step by step. So the first important point that we already discussed about is, if you want to read the input from the keyboard, you have to import the scanner class that we are doing in the very first line. This is line number 4. In fact, we are importing the scanner class. Then I'm directly coming to the code that is written inside the main. So here we have created one scanner class object. This also we have discussed in one of the previous video lectures. Then next will ask you to input the size of the matrix in terms of rows and columns. So in response to this, you will type uh, a number twice, because you are supposed to input a square matrix, and for the square matrix the number of rows and columns should be the same. For the rows, I'm using variable m of type integer, and for column we are using variable n. So these two statements will read the values of m and n from the keyboard respectively. Then we are allocating the memory for the arrays, as we discussed in the previous video lecture day before, yes, on Friday. So this will allocate the memory. New is the keyword that is used to allocate the memory, and then after you will write the data type of the array. After that, number of rows in first pair of square brackets, and number of columns in second pair of square brackets. So we are allocating basically only one array is required. So I'm going to delete it because I have copied it from the previous problem. So there is only one array, and we want to just find out the swap transpose of the matrix in place. In place means we will not use extra array to store the transpose. We'll find the transpose in place using one array only, A itself. So the next line will display you input m into n matrix. So because the value of m and n will be the same, this is the prerequisite condition for the square matrix. So you will get this input 3 by 3 matrix or 4 by 4 matrix. Then through keyboard we are reading a two-dimensional matrix using nested loop. So this is clear to you because we have already discussed about nested loops in Java. So this statement will read one element at a time and will assign that element to AI J. Here I is the row number and the J is the column number of the matrix. And then the next nested loop will print whatever you have read through the keyboard on the screen. So using this, we are displaying the same matrix again that we have just read through the previous loop. So because we want to print all the elements of one row in one physical line, so I'm using over here print instead of print ln, because println inserts the new line character at the end of every line. So that's why I'm using print here. So this basically inner loop will print one row, and after printing every row, I want to print backslash n, means want to shift the cursor to the next line. So for that, I have used this print ln method. So this will print the same array again that you have just inputted through the keyboard. Then this is the logic of the problem that we discussed. Actually, we want to transpose this and this element, then this and this element. So I'm using I outer loop I is equal to 0, I less than here n is the number of rows, and I'm starting the value of every upper element, the element that is above the diagonal, the number of the column will be greater than the number of the row. So if I is 0, I'm starting j from 1. If I is 1, I will start j from 2. If I is 1, I'm starting it from 2. So this will be the 2, right? So this is the case. That's why we are doing this. So what we are doing, we are interchanging I jth element with j ith element. If this is 0 1, we will interchange it with 1 0, this one. So ij, if this is ij, then this will be ji. So here the logic is very simple. We are swapping I jth element with j ith element. So this is the logic for swapping the two elements. And after that, we are printing whatever is there in A, so you will get the transpose through this matrix. So this logic is very simple. I'm going to run it now for you to check the result. If there is any doubt regarding the logic, you can leave your doubts in the chat box. So for you, I'm going to run it. I'm going to click here. So when you will click on the run button, it will ask you the size of the array. So I am going to input over here. The size of the matrix is 3 by 3. After that, this loop will ask you to input 9 elements. That means 3 into 3 matrix. So I'm going to input over here. 1, 2, 3 is the first elements of the first row. These are the elements of the second row. 5, 3, 9. These are the elements of the third row. So if you just look at the output, I'm going to show you this one. This is what I entered through the keyboard. So before the transpose, this loop is printing this result 1, 2, 3, 6, 8, 9, and so on. Now after transpose, so this will get exchanged with this. So you will get 6 over here and 2 here. So 6 is here, 2 is here. Then we exchange this and this. So 4 is here, 3 is here. Then we exchange this 9 with 3. So 3 and 9. So this is the transpose. So I think you all get it right. So now let's switch to the next problem on Java. This is the next problem, and in this case what we want to do is we want to rotate the elements of one-dimensional array by k positions clockwise. So first of all, let's understand the problem, then we'll discuss its coding. So let's suppose this is your array. The elements of the array are these. The array size can be any. So I am assuming that the array size is 6. So 6 elements are there. If I want to rotate it clockwise by one element, then this 50 45 will go to this place. So I'm going to write it here. If you rotate it clockwise by one element only, the 7 will become the first element, 12 the second, 5 is the third, then 3, 8, and 45 will get added at the end. So the list that I have written on the right hand side is basically the rotation of this array by one position clockwise, right? So this will be added to this. Now if I rotate it by two elements, then this will be the position, the third element, this one, this will become the first element, then this the next element, and this first element 45 will go to this place, and the 7 will go to this place. So this example is basically rotation of this matrix by 2 positions. So first 2 elements will get added at the end. So this is what we want to do. So how we have coded it, we are going to discuss this. So first point is, again we have one scanner class that we have imported using this import statement. This line will create the object of the scanner class as we discussed earlier. Then we are creating two arrays. One is A, other is B. In A, will read the elements of the array, these 6 elements, and after rotating the elements of the array clockwise by k position, will store the result, this one, in array B. So for result we are using array B, and for storing the elements we are using array A. So this line will read from the keyboard size of the array. Right? So this line will ask you to input the number, and the number that you will input will get stored in variable n on the left hand side. Then we want to read the array elements. So this loop will read n elements into array A one at a time. So then this line will read the positions by which you want to rotate the elements. So if k is if you input 2, then this will be the value of the k, right? So this loop, and this is very simple. So the main logic is this, how we are getting the output. So if we look at the example that I already gave you, if I rotate this matrix by 2 position, then this element, this is basically the second element, will become the 0th element. Third element will become the first element. How we are doing that? For that, we have used this expression I plus k remainder n minus 1, because the last index of the array will be n minus 1. So this is, if the size is 6, then this element position will be 5. This is at position number 0, 1, 2, 3, 4, and 5. Now, if this is the second position, uh, what I am doing is I am using this loop I is equal to 0, I less than n. So I am checking every element of array A. So when I is 0, so 0 plus k, let's say k is 2, so 0 plus 2 is 2. Remainder by 5, I am assuming the size is 6, so 6 minus 1 is 5. So 2 remainder 5 is 2. So A of 2 will get stored in B of 0, because the value of B is 0. When the value of I will change to 1 with the next iteration of this loop, and 1 less than 6 will be true. So this will 1 plus 2, value of k, 3. 3 remainder 5, 3. So A of 3 will get stored in B of 1. So then when the value of I is 2, so 2 plus 2 is 4. 4 remainder 5 is 4. So this A of 4 will get stored in B of 2. When I is 3, so 3 plus 2 is 5. 5 remainder 5 is 0. Right, so it should be, let's check it. I think it should be n. It should be n. Should not be n minus 1. So if this is I is 3, so 3 plus 2 is 5. 5 remainder 6 is 5. So this A of 5 will get stored at B of 3, right? So I think you got it right. After that, we are displaying the actual matrix that is in A with this loop, and the matrix after rotating k positions, we are printing the matrix B. So these two are just printing loops that are printing the elements of the array. Let's check it. I'm assuming the array size is 6. For simplicity, I'm starting the elements from 12, 13, next element 14, 15, 16, and 17. These are the elements. I want to rotate this array by 2. So if you rotate by 2, the 14 will become the first element. Look at this. This is the output. 14, 15, 16, 17. 1 and 12 and 13 are added at the end. So here I should add one backslash n because we are getting this at the end of the input line, right? So this should be there. I think you all get it right. I'm going to run it again after making a minor correction over here. I have entered backslash n over here because it is getting it's displaying the output, this output on the same line with the previous. So I have added backslash n over here. So let's check it again. This time I'm assuming that again the size of the array is 6. Then these are the elements 90, 80, 70, 60, 50, and 40. Want it to rotate by 2. So this is the actual array 80, 90, 70. If you rotate it by 2, this third element will become the first element, right? So you can verify it for different values of inputs, right? So the main logic is this we discussed. So you can implement variation of this program as well, where you can rotate the one-dimensional array anti-clockwise by kth position. This is the clockwise, and you can verify that, implement it yourself. So this is about this another second problem on array. Now let's discuss the third problem, almost based on the same concept. This is the problem that we are going to discuss now, swapping two rows of a matrix. So if I show you the example again, this is the example that I'm going to add it here. So the example is, if I have one matrix, let's say this, and this is basically a 3 by 4 matrix. So what I want to do is, if I, let's say, if I interchange or swap the 0th row with the third row, right? This is our input. So I'm going to write over here. This is the input, and the output should be after the swapping of two rows. I want to swap, let's say, 0th row with the second row. Then this should be the output. 2, 3, 1, 4 should become the first row. Second row will remain the same. 7, 6, 5, 3 are the elements of the second row, and the first row, that is row number 0, will become the second row, right? So this is the case. So how we will implement this problem, this we are going to discuss through the code that I have already written over here. So again, m and n are the rows and represents the rows and columns of this matrix. and R1 and R2 are the rows that we want to swap. So if you want to swap 0th row with the first row, then the value of R1 will be 0 and R2 will be 2. Then again here these two lines, as we discussed in the previous problem on arrays as well. First it will asks you to input the size of the array in terms of number of rows and number of columns. So this line will read the number of rows and this line will read the number of columns. Then the next line is allocating the memory using the new keyword, as we have already discussed. Then through this loop, we will input m into n matrix into the computer. So this will read the matrix that you will input into array A. So again, I'm not going to explain it again because we have already discussed this loop twice in the same video lecture. So the next line is will ask you to enter the row numbers to be swapped. So this will read one number into R1 and second number into R2. So the next loop, this loop will print the matrix that you have entered into on the screen, right? So this is before swapping the rows, you will get the matrix on your screen. Again, I'm not going to explain it, how this is printing the result on the monitor screen. If there is any doubt, you can leave your doubts in the comment section or in the chat box, right? I'm going to discuss just this loop because this is the main logic of the problem. So what I want to do in this case is I want to swap. If we look at this problem again, if I want to swap 0th row with the row number 2, I will swap this element with this element. So 2 will come here, 1 will go down, and 6 and 3. So this is the case, 7 and 1, and 8 and 4. So we are swapping every element of row R1 with every element of row R2. So how this will happen? For that we have used one loop, j is equal to 0, because we want to swap the first element, that is 0th element of row 1 with the 0th element of row 2. So R A R J, so R1 is, let's suppose it's 0, so R0 0, J is also 0 in this case. So we are copying R00 in T. Then we are copying R2. We assume that the value of R2 is 2, so 2 0 in A00, and then we are copying T in A2J. So this basically swap the every element of the row R1 with the every element of row R2. And after that, this nested loop will print the matrix Aij on your monitor screen. So let's check this. I'm going to run it. So I'm going to input the size. Number of rows are, let's suppose, 4, and number of columns are 3. So I'm going to enter the inputs. Number of rows are 4. So 4, 5, 6. This is the second row. 7, 8, 9 is the third row. And let's say this is 3, 2, 6 is the fourth row. If you enter this, now I want to swap row number 1 with row number 3. So let's check the output. This is the matrix that you entered. So this is the exact matrix. So we want to swap first row, so that is this row, with the third row, that is this row. Keep in mind that the first row is row number 0, so row number 0, 1, 2. So this is row number 3. So if you swap this, so look at this. Now this is row number 3rd, and this one that is highlighted on the screen is row number 1. So I hope you get it right. And now let's move on to the next problem on arrays. The next one is this, and in this case we are basically rotating the two-dimensional matrix by rows. So what does this mean? We already rotated a one-dimensional array by k position, and here we want to do the same thing but on two-dimensional array. So first we will rotate the rows, and then we will discuss how we can rotate the columns. So I'm going to show you one example over here. So what this logic will do actually. First, let's say this is your matrix, and these are the elements of the matrix, and I'm assuming this matrix is 4 by 4. This is your input. So if I write over here input, this is the input matrix, and I want to rotate the rows of this matrix. So this means if I rotate the matrix by 1, so that means this 0 number row will go down. So if we rotate it by 1, this should be the output. I'm just copying it. This should remain the same, and the row number 1 will be added to the last. So this is the meaning of rotation of rows by one position. If I rotate this matrix by 2, that means these 2 rows will get added at the last. So I'm going to show you the example again. This is the rotation of the actual matrix by 2 rows. So the row number 2 will become the first row, and so on. So in this case, how we can perform the rotation of a two-dimensional matrix? So I'm going to quickly show you the code of this. Whatever part we have already discussed, I'm not going to explain that. So quickly, I'm going to explain the terms. So this basically up to here, this will first read the array size. Then these two lines are allocating memory for array A and B, because after swapping, we want to store the output in matrix B, so we have used the second matrix as well. So this matrix will this loop will read the input through the keyboard as we discussed earlier. Then it will ask you by how many rows you want to rotate it. If you input 2, then that means the third row, that is row number 2. If you want to rotate it by 2, this one, then that means that the first two rows will added at the end, and that means the row number 2 will become the row number 0, and the rows, first row and second row, will be added at the end. So what will happen? See, this will read the value of k. After that, before rotation, we are again printing the matrix that we just read through the keyboard using this nested loop. And here is the main logic of the problem.
That's amazing.
What we are doing in this is this is the main concept. So basically, what we want to do is we want that the rows should be shifted by 2. So I am going to write over here. See here, if this is row number 0 actually, so the row number 0 will become the row number 2 in this case. This is the input, this is the output. So if I rotate it by 2, this element in row number 0 will become the elements of row number 2. So how this will happen? We have added over here I is plus k, the value of I'm assuming it's 2. So 0 plus 2 is 2. Remember, the m is the number of rows. So in the example I have just shown you, the number of rows were 4. So 2 remainder 4 is 2. So the A20 will get stored in B00. So A20, this one, A20 will get stored in B00, right? So this is the element. Then next, if you look at the next iteration, when the value of j will change to 1, so in that case 0 plus 2, 2, remainder 4 is 2. So A21 will become the value of B01, right? And when the value of row number is, let's say, 2, right? So in that case 2 plus 2 is 4, 4 remainder 4 is 0. So that means BA00 will become the value of B20, right? We assume the value of I is 2. So you can verify this logic by using copy and pen. So this will give you, this simple logic will swap the matrix, not swapping, it will rotate the matrix by k number of rows. Then we are printing the output that is already there in matrix B using this nested loop. So let's check the output. So I'm going to increase the size of the output window here. So let's run it first. So it's asking us the input in terms of number of rows and columns. And let's suppose the size of our array is 4 by 2, suppose, right? So the number of rows are 4. This one is the first row, second row, third row, and fourth row. We want to rotate it by 3 rows, please suppose. Now this was the actual matrix. If you rotate by 3 rows, so that means that the first 3 rows will be added at the end. So this row number, last row, that is row number 3, will become the first row. So you can easily verify the result. So the last problem that we are going to discuss on array is how we can swap the columns. So I'm not going to explain it entire. The logic is same almost. The only one change is there. If you want to rotate the matrix by rows, then you will put over here the expression I plus j remainder m. If you want to rotate the matrix by columns, then you will put j plus k remainder m. Right, so it depends where you are writing the expression. So I will just verify the output because rest of the program is same, only a little change is there. So you can verify this output. I'm going to show you here just output of this problem. So I'm going to run it first. Let's assume again the array size is now it's 4 by 4, let's say. The first elements are this, the second row elements are this, third row elements are these, and the last row elements are this. And I want to rotate this matrix by 2 columns. So that means this third column will become the 0th column. Now look at this output. This is the actual input that we entered, and this is the output after rotation. So this, because we rotated it by 2 columns, so that means the column number 2, this is column number 0, 1, 2. So this will become the first column, then the third column will become the second. First one is at row number 2 now, column number 2 now, and the column that is at first place is column at third place now. This is all about the problems on array. I think you all get the problems right. If there is any doubt, you can leave your doubts in the comment section, or you can leave your doubts in the chat box. Shoot your doubts. I'm going to